Alright, let's get started with today's problems. And just as a quick explanation for why there weren't any uploads yesterday, or well, rather the day before, I had received 2 online assessments from JP Morgan Chase and Capital One. I did both of those yesterday during my normal study block and was very, very exhausted afterwards, just having those back-to-back online assessments. I did alright, I think, but nothing spectacular. But in any case, let's get started with today's problems. So, our first problem of the day, once this actually loads up, is LeetCode number 525, Contiguous Array. Given a binary array nums, return the maximum length of a contiguous subarray with an equal number 0 and 1. Okay. So, longest contiguous array with the same number of ones and zeros. This kind of feels like a sliding window question, where we would say start with the sliding window of size 1. And then while the numbers are not equal, grow the array. While the numbers are equal, shrink from the back or from the left. There's also a chance that it could be a dynamic programming question where at each point we decide whether or not to continue the previous array or to leave or to start again at that particular index. And then in that case, it would be the longest, or the length of current cell is equal to the max of. It would either be the max of the previous, so that would be index minus 1, dp at index minus 1, or maybe, it would have to be that of 4, or I guess all I from 0 to index minus 1, where the number of zeros and ones are not balanced, and adding current would make it balanced. That sounds like an interesting idea. This would be O of n squared probably, runtime. So at that point we would basically like start from our current cell. We would look backwards and see like, okay, so our previous, what was our previous maximum at that point? And so on and so forth. Let's see. We know that there are 2 edge cases, no matter which approach we decide to take. That would be if nums.length is equal to 1, we return 0. If nums.length is equal to 2, we return 2 if 1, if 0, nums at 0 is 0, and nums at 1 is 1, or nums at 0 is 1, and nums at 1 is 0. And of course these are in parentheses. The idea is that if there is a size of 2, then they either have to be 1 and 0, so one or the other, for each, or it's not balanced at all, and we can't make a contiguous array out of that. Okay, when we expand it to size 3, at 3 we can have a maximum of 2. At 4 we can have a maximum of 4. So the length is restricted to be even. Must be an even number for hopefully obvious reasons. I mean, the idea is that we need to have an equal number of zeros and ones, and we can't have an equal number of zeros or ones if we have an odd-sized and odd-length subarray. Okay. Maybe then in that case, for this dynamic programming, we don't need to check all of them. Maybe we only need to check n minus 1 and n minus 2. So if we want if n minus 1 let's see. If n minus 1 well, the idea is that we want to either continue the array from that point, or we want to start a new array, right? So if we start it there, I think it makes sense. I think the dynamic programming approach is what I'm thinking of, but I'm just having a hard time trying to think of the subproblems. Is it all of them, or is it a specific subset? I have a feeling that it's all of them, but we could start with that, and we can think about this. We can continue to think about whether or not we only need to check a handful. I think the idea that I was going for is that, say we had an array that was balanced at n minus 1. Say we had a balanced array at n minus 1, then we can't add on to it. We must have an imbalanced array to continue that. If we instead had an imbalanced array at n minus, or a balanced array at n minus 2, then we must make sure that n is not equal to n minus 1 in terms of the actual numbers, right? So the idea is that we have a balanced array at n minus 2. As long as our current 2 additional values are different, then we maintain the balance. If we have an imbalanced array at n minus 1, we need to make sure that our value is the same, or is the missing value. And so maybe otherwise the value at that array is 1. Restart. Do we need to check n minus 3? N minus 3 would only work if it was imbalanced. And if n minus 3 is imbalanced, then we need to make sure that we have within n minus 2, n minus 1, and n, that we have at least 3 values, or 2 values, which are the missing values, and we must have an imbalance of no more than 1. Interesting. So if we had something like 0, 0, 1, 0, 1, longest array would be this. So here, in the DP part, we would have initialize them all to, technically, right? Initialize them all to 1. And then for here, this is just 1, this is just 1. We start at the third value because that's the only way that do we start at the third value? Sure, we can start at the third value. We can say, okay, is the array at here, is the length, is the array balanced here? In this case, maybe we have a balance array, which is false, false. Initially, all of them are set to false. And then here, okay, so n minus 1 is imbalanced. Therefore, we can add on to this, and we can restore the balance, and increase the length by 1. So now this is 2. And here this is false, false, true, false, false. Okay, and then now this 0 sees that the previous value was balanced, but the second previous was not balanced. Now I'm thinking of whether or not this, let's see, do the problems overlap? Because clearly, like, okay, we can have this, right? So in that case, we go to the previous value. The previous value is a 1. And so we can at least have 2, right? But how do we obtain the full thing? Right, because then it would be 2, this is balanced, sure. Like false, false, true, true, false. Like, in this case, we have previous value is opposite of current. But we realistically want a 3 to be here, but we don't know because we haven't actually checked if the next value is a 1 yet. So we could have either have a length of 2 balanced or length of 3 imbalanced. And the 3 would actually work better, but Maybe we just take a value in the hopes that it gets balanced. Let me think about this some more, because feels like I'm starting to feel that like maybe dynamic programming isn't what we want, actually. I'm just thinking whether or not the problems overlap. And if so, like sort of what are the problems? What are the sub-problems? Because not necessarily are all the values paired, right? We can have something like this, like 0, 0, 1, or 0, 0, 0, 1, 1, 1. But that wouldn't be balanced until like we have a balance here, and then we balance here, and then we balance here. But how do we like sort of deal with that? Like, do we just create a num zeros? So 1, so if we had like a +1 if equals 0, -1 if equals 1. But how does that help? Because at every point we could potentially restart. Point could potentially be the start of a new array, or subarray rather. Right, for example, in this one, we do 1, and then we actually want to start here, like, so 2, 1, 2, 1. So long as a value has a value of 1. But realistically, if we started on this tile, it'd be 1, 0, 1, 0. But, like, how do we figure out, like, sort of where that starts then? Maybe the idea is that if we did all that, right? If we had this 1, 0, 1, 0, we could link this up in some way. Is there any way that we could potentially like link this up? Let me think. So linking it up, let's say that we had a bunch of, like a string that goes up and down and all whatever until it eventually arrives at 0. Okay, but like where does that start, right? Like we've reached a 0, but we don't know exactly where it starts. Because for example, this one would be like 0, 0, 1, 0, 1. And this would be 1, 2, 1, 2, 1. And then in this case, we don't have a starting point. Unless we want to start from here and be like, okay, 1, 0, 1, 0. But then we potentially miss, like, if we had like a better value on this side, then we would miss that. Dynamic programming. We can choose to either continue a subarray at some point, but it must include our number, or we can choose to restart our values entirely and start at 1. Sure, but how do we know the previous values at those points? At those subarrays. We don't really know the values of the 1s and 0s at those subarrays because there are just so many to deal with, right? So if we had a size 0 or size 1, that would just be 1. If we had 2, because if we had a value like, for example, 0, 1, 0, like in example 2, we have 2 potential two potential combinations of 1 and 0, though they are the same, right? It's just it's either a 0 and actually it can be, so combinations that we have 0 or 1 0 1 0 1 0 and 1 1 1 1 and 2 zeros and 1 1. Right, so we have these individual combinations, and at the end here we can choose to either take the 1 1, we can join up with the 1 1, or we can join up with the 0 1. And if we want to go further than that, well, we could potentially have something like a 0 0 1 1. And in that case, we'd have to check, okay, I can match with this 1. I can't match with this 0. I can't match with this 0. I can't match with this 1, but I can match with all of these. So do we just want to do that then? No, because the number's length is num's length is less than or equals 10 to the 5. So that implies that this should be an O of n solution. Let's see. If we had this 0 0 1 0 1, let's create our we'll call it a point array, where the zeros add 1 and the 1s subtract 1, and then we'll have a starting if we store the start value, right? And then we say, okay, in that case, let's remove the first value. So that becomes 0, 1, 0, 1, 0. But then how does that even work? Like, okay, so we have those values. We see two pairs here. But how do we know that they can work besides each other? I guess if they're both both halves of the subproblems reach 0, then we can join them together and still maintain evenness. Hmm. I mean, that could work. And then we just update all the values. And then we see from there, like, oh, okay, so if it has a value of 1 behind it, or if it has a value behind it, and it reaches 0, then we're fine. We just excluded the first value. But, like, what about excluding the second value, or the third value, or the fourth value? Or from the end, what if we wanted to exclude the last value within our array, right? Feels like there's something here, but it just isn't quite enough. There's just not enough constraint here in order to make this work. I don't think that it's a divide and conquer problem. I think the problems do overlap enough. We can't just split the array in half and expect it to work, because we kind of need these like pairs, right? Hmm. What if we did the scoring thing? But did it closer to 0? Or like kept... So like here... No. I was gonna say like what if we decided to keep, like, we can choose either between maintaining previous or like resetting to 1. But like, for example, if we did something like 0, 0, 0, 1, 1, 1, we actually do want to go like 1, 2, 3, and then 2, 1, 0. We don't want to be like resetting here and saying like, oh, 2, 1, or 1, 1, 1, and then like 0, 0, 0. If we did that, that would be 1. And then 2 is less than or greater than 1, so we take 1. And same here. And then here we could subtract 1 because the previous. That's fine. But here we don't want to go into negatives, and here we don't want to go into negatives. But the problem here now is like, okay, yeah, but how do we join them together? Well, we're at the 30-minute mark, and I feel like I've gotten close to a solution, but I'm nowhere near understanding it, like, sort of, or like getting to the point where I feel confident in it working. So I guess it's time to take a look at the solution, and I'll be right back after I sort of get a grasp of it. Okay, so we were actually a little bit close to the answer with respect to that score system that we were talking about. But I think the main thing that I missed was that when it comes to the context of having the score count like that, just because a score is not at 0 does not mean that the array is not balanced. Because, for example, if we had something like 0, 0, 1, well then, assuming that for a 0 we increment and a 1 we decrement, then we would have a scorecard or a score that goes 1 to 2 to 1. Now, of course, at this 1 over here, we know that the previous pair, the 0 and the 1, can constitute a balanced contiguous array. However, it's not at 0 because of the fact that we have an additional value. I think I did try to sort of correct for this mistake, but the sort of easier way to approach this is to say, okay, we know that we have this balanced array, and we know that if we combine balanced arrays together, that we will have, well, another like a larger balanced array. So in that case, have we ever encountered another situation or another index where we have been at the same score? Because if we were at the same score, then in that sense, we have a situation where both of the times, or at least from what I understand, when we have another score of the same type, at that point we have essentially another balanced array, and we can combine those two arrays together. And so the larger array will essentially be the difference between our current index, where we have a score, and the oldest instance of that other score, and that will be our total array combined size. So that's essentially what the solution does. I decided to go with a Hashmap. There is another way to approach this using an integer array. So I start by tackling some of the edge cases. Then I start by declaring the score, the max length, and the map. Then after the max length and the score map, I go ahead and insert this value 0, -1. Now the key of our hash map will be our score, and the reason is because we want a fast lookup for if we've ever encountered this particular score before. So at -1, we will declare that that has a value of 0, because before we've entered the array, an empty array is balanced, right? So we start at 0 at -1, and then we go ahead and we iterate through the integer array. In my case, if I see a 0, I increment the score. If I see a 1, I decrement the score. You could choose to do it the other way around, where if you have a 1, you increment, 0, you decrement. It's personal preference. It doesn't affect the answer at all. Now, we check to see if we've seen this score before. So we go and check the hash map with the key of our current score. If we haven't seen the score before, it's pretty straightforward. Then we will simply add it into our hash map. In case we encounter that score again, then we can say, okay, those two arrays halves are balanced, mash them together to create a larger array. If we have seen it before, then we know that we have a potential larger value for our balanced array. So we go ahead and get that score. In this case, we know that this will be non-null, but Kotlin's sometimes a little bit weird. And then we go ahead and we check to see if this new mashed together array is a longer length than our previous. And in that case, then we will set our maximum length to be that. And then at the end, we just return our maximum length. We don't need to update our values if we've encountered another score of the same type, because naturally the largest array or the longest array that we can create happens by getting the most recent value, and the oldest instance where we've encountered that score. It's a little bit weird because when we subtract the indices, we kind of go with the index that of a value that isn't actually included. So it's actually the value before the one we want to include. And I think to a certain extent, that's probably why we also include the -1 in there in the first place. So for example, like if we did, I think the solution went through one of these values. So when we go through this value, our length is actually, the length that we use is actually our current index, so 0, 1, 2, 3, 4, right? So we take our current 4, and we actually subtract by the index at 0. So even though we don't actually include the 0 within our array, we use it, we use that as part of the calculation for the maximum length. So in this case, let's go ahead and submit, and let's see if there are any changes that we need to make. And looks like it was accepted. And yeah, so that's pretty much the solution. It's a little bit weird. I think we got close to it using the score idea. I just couldn't make the connection that it wasn't necessary to have a 0 within the score in order to sort of combine the pieces together. But in any case, I hope you learned something, and I'll see you for the next problem.